In this video, we're going to design, test, and build our version 2.0 waste oil burner. In the first video, which I'll leave a link in the description below, we built this version 1.0 waste oil burner, aka a smudge pot, and it was a really basic design I had seen on the internet and I wanted to test it out. Now, I really do like this burner, however, there were a few design flaws in it, and I want to address those in today's video, and that'll take us to the waste oil burner 2.0. I broke down the design issues with this into about 4 different categories. The first issue is the riser and all the cutouts in it. I was just doing things that I'd seen online and wanted to try it out. Now, I do believe all those cutouts are not allowing the flue or the riser to get up to temperature, which is definitely not helping the burn. Issue number 2 is the squareness of the flue and the burn pot. It doesn't allow for really fluid air movements. I think that's also contributing to a poor burn. Issue number 3 is that we just have a pot of oil on fire. We can only control the air in. We have no control over the fuel itself. And then the 4th issue is really safety. You have a pot of very hot oil. If this gets hit, knocked over, it'll turn into a really big ball of fire. And yeah, that is a little bit scary. So let's go back and I'll take you through the build process and try to explain some of the design changes I made to correct all those issues. I then want to run a test of 4 fuels: kerosene, diesel, used vegetable oil, and a waste oil and diesel mix. I want to see which one I can get burning the cleanest, learn their characteristics, and try and gauge which one burns hotter and longer. The building of version 2.0 really is not that much different from building the first one. I start my design in CAD, I send the file off to the CNC table where the plasma cutter cuts out all the shapes for me. Then the favorite part of any build, grinding. You got to clean up all of the plasma cut edges. The stainless doesn't cut perfectly, it leaves a bit of dross, and cleaning all those edges up just helps so much with TIG welding everything together down the road. When I'm done cleaning up all my parts, I use a combination square and a scribe, and I scribe the bend lines on all the pieces that have to get bent. Then we're over to one of my favorite tools in the shop, and that's the box pan brake. Being able to bend materials not only makes a much cleaner look on a final product, but it saves so much time in TIG welding all of the corners together. I've only had that machine for about a year, but I absolutely love it, and it's been coming in handy. I also CNC cut some preset angle markers so that I know where to stop my bends. Because I'm going between 90s and 120 degrees, it was easier just to use a gauge versus set the bender to the preset angles. With the majority of the parts bent, it turned into assembly time. Weld in our inlet air tubes. And then get the burn pot tacked together before fully welding those 2 seams and all the tapers. Make sure the bottom fits nicely, and then I tacked all the corners before fusion welding all of the seams. I didn't even need filler here because those edges were so nice and clean. I kept a really small bead and you could just walk the torch along and it laid in beautifully. I didn't overheat the stainless either, so I finished up with a pretty nice looking weld. Then you basically repeat the same process for all the other components. This is the inner part of the riser. You can see all the cutouts there, which are going to provide hot air for our secondary combustion. I suppose this is a good time to explain the design of version 2.0. To try and solve issue number 1 of the flue not getting hot enough because of all those cutouts, I decided to go with a double wall design. The inner part of the riser has perforations near the top, and then the outer part of the riser covers all those up, almost going down to the bottom. What this is going to do is allow the temperature in the flue or riser to get much hotter. It's going to pull cold air in from the bottom, get it nice and hot, and then inject it into the top of the flue where any unburnt gases should ignite. This is known as secondary combustion. It works really well in the wood stoves that I own, and I wanted to bring this feature in as a way of trying to make sure that we get a complete and clean burn. Issue number 2, with having the square shape not allowing a very fluid flow, I decided to go with a hexagon. Ideally round would probably be a better shape, but I don't have a slip roll, so a hexagon is just going to have to do. With assembly well underway, it was time to fit the outer wall of the riser. It took a little bit to get a nice snug fit, but eventually I got it on there, and then I proceeded to weld it in fully. This was a bit of a mistake, and it's going to come back to bite me a little bit later on. With that welding complete, I moved on to getting the legs on. I wanted to get this thing off the ground a little bit, make it look kind of cool, and I figured a nice little tripod design with some 3/4 inch stainless tubing would be just perfect for this build. Then we reached a point in the build where we had enough of it together to do the first test. I thought it was a good idea to stop here, light it up, and see how it was working before we continued on with the build, and it turned out to be a good idea because I did have to go backwards. What I noticed here in this first test that we did not have enough cutouts in the inner riser. The bottom burn pot was burning, and then it would create a lot of combustible gases, at which point they would finally ignite on the secondary combustion at the very top. But this isn't really what I wanted. I want the burn happening throughout the riser. So it was time to go back to the drawing board and go backwards a little bit. Since those inlet air tubes were actually creating a pretty nice little vortex burn if you've seen down the riser, I wanted to continue to help that out. So I made marks at several different levels around the riser, alternating as it went up. Then I took a zip disc, tried to cut out 2 little slits, and then I took a punch and knocked them in. My theory here is that when it draws air in, it's going to kind of draw it in at a slight angle and maybe help continue that vortex burn all the way up the riser. Then it was time to put that outer shell back on. But this time I learned, I just tacked it instead of fully welding it on. And then on to test number 2. Well, I'm going to have to say that I think that's about as much as we need to do on the riser. I think it's grabbing all the air it possibly can and wants. And I think that because the secondary combustion holes at the top aren't really burning off much. So that means we're having a full burn. It's hard to show on camera, but it is full flames from the burn pot all the way up through the top. In my mind, this is like worst case scenario, right? We have a full pot of oil off gassing that is mostly burning off. There is an ever so slight touch of smoke. It's really not that bad. You can't even smell it. Now, when we add in the oil drip system, we'll be able to control the fuel, and potentially we'll add some dampers to control the air. I don't think we need to control the air if we're controlling the fuel. So the next steps are to build a oil pot and a drip system so we can control the flow of oil going into the burning chamber. And by being able to control that, we should be able to dial this into basically smokeless. And if we were running straight diesel, it probably would be already right now. As I mentioned, we're going to use an oil drip system to control the fuel in this burner. That's going to require an external fuel chamber, with a needle valve located at the bottom of it that will allow us to finally adjust the drip rate and the fuel flow into the burner. There's a few advantages to this. One being that now we do have full control over the fuel. We should be able to maintain a little or a large flame as desired. The second being that now we don't have a full pot of oil boiling, so it makes it a lot safer. And a third is we can now easily refill this as it's burning. To go along with that oil drip system, I wanted to create a bit of a metal wick. So I found this really fine stainless steel mesh that I'm going to install into the bottom of the oil pot. My theory here is that this mesh will heat up quite hot, and as the oil drips onto it, it should wick out and off gas, improving the burn. And if you think this mesh is just going to melt down, trust me, I thought the same thing. So I grabbed my blowtorch and it will heat up bright orange and it won't melt. To light this one up, I found it's pretty easy to just stick some newspaper down inside here, run a little bit of fuel, and then ignite this paper with a blowtorch. You can try and light the paper with a lighter and stick it in, but doing it like this works really well. Okay, Carter, can you run a little bit of fuel to kind of prime it?
It's running.
Okay, turn it off. Perfect. Now let's light it up. Watch out a sec. And then we're using a kerosene vegetable oil, used vegetable oil mix. And we just set this to a nice little drip.
That's a run, not a drip.
Thank you. Okay, there's a good little drip, and we'll check on it in a couple of minutes. Okay, this has been completely empty for a little bit. We're going to start with 600 milliliters of kerosene, and this is really the cleanest burning. It's so filtered, there's very few impurities in there, and when you dial it in, this really is basically smokeless. It's just pretty expensive. The beautiful part is you can change fuels as this is running, unlike the other version. Carter left it open. Because each fuel has its own viscosity, it kind of takes its own drip rate to dial in. And it's a little bit of practice, but once you get it, this little needle valve makes it quite consistent. All right, I'm just gonna keep track of how long that takes to burn off, and we'll try and use an IR gun and see what temperature it gets up to. Something I'll mention too is each fuel also has kind of its optimum burning range. You turn it up too high and it becomes a very sooty flame, throwing off a little bit of smoke. Or if it's burning too low, it's not actually hot enough and combusting and burning at the right temperature. So once you kind of dial each fuel in, which seems to be flames just licking out of the top of the stack. That double wall really does create secondary combustion, and it's really hard to see on camera, but you can see flames jutting out all the way up where that hot oxygen is mixing with the unburnt gases and reigniting. So this is a little too much for kerosene. I'm just gonna dial it back ever so slightly to just barely a stream. There. That is basically smokeless. That puts the outside around just over 600 degrees Fahrenheit. Down inside, well, it maxes out at over 1,000. This is just a cheapie. Just like down in there. Yeah, maxes out. Well over 1,000 degrees inside. Once that tank runs out, we're going to run used cooking oil next. That one burns surprisingly smokeless. It smells pretty good too. Another thing to make note of is I used some of that stainless steel mesh to screen this oil, because with that needle valve, any particulate from a fryer will plug it up. Ask me how I know. Okay, used cooking oil. Gotta adjust the valve because it's a lot thicker. We got it turned up pretty good here. What are we seeing for temperatures? 550. It's not able to get itself as hot as the straight kerosene can, which kind of makes sense. It's not really meant to burn. Something I've just kind of picked up on is this is going to be a really hard thing to compare as far as time goes, because we're using different fuels of different viscosities, so you can't leave the drip rate the same. You need to adjust it to get it burning properly, which then changes everything about it. So I think the time comparison is going to be essentially meaningless, because you can make these burn anywhere from 10 minutes with a really big burning flame to 20 maybe plus minutes on that 600 milliliters of fuel, which is pretty good, because that takes us to what, an hour is a couple of liters, which I think our hopper is about 1.5. So, and you can refuel it as it's burning. Huge design improvement. Here we have our used vegetable oil. There is like no smoke at all. There's really no smell, and if there is, it doesn't smell bad. Very clean burning, and when you get it dialed in, it's awesome. So if you are in a urban environment, this one is not too bad and probably won't piss off your neighbors. All right, and in with the used oil diesel mix. There we are. That is a 50-50 mix of waste oil and diesel fuel, and it's got dialed in perfectly. Flames are just licking out the top, and it is burning almost smokeless. I'll admit there is a little bit of smoke as it changes, but it is pretty good. Very little odor. There is a little bit. Used cooking oil and kerosene I find is the best, but this is not bad at all. All right, in with the diesel. Woo. Yeah, I gotta close that valve up a bit. That just takes a drip. All right, well, there is pure diesel. It's been running on it for a little bit now, and there really is not much smoke. I don't know how it looks on camera. I got it dialed in just like the rest of the fuels, where the flame is just licking out the top. And the odor, I mean, there is a little bit. You can tell a fossil fuel is burning, but it's really not that bad. I don't think anyone 100 feet away would even know. Well, this testing was kind of neat. I learned some things I wasn't expecting. And the first thing is that it was really hard to measure the time at which any fuel lasted because of the different thicknesses and flow rates. You had to play with things, and time kind of didn't matter anymore. I'd say any fuel lasts between 10 minutes and 20 minutes on that 600 milliliters. The other thing I learned is when you kind of dialed in any fuel, it burnt right around that 6 to 620 degrees Fahrenheit quite consistently. I must say I wasn't really expecting to learn that all 4 fuels are kind of the same. I know some viewers made comments like that. The waste oil and diesel mix kind of gave you the best of both worlds. It seemed to have the longest burn time and the most BTU. However, it did have a bit of odor and a bit of smoke. So, you know, urban areas, yeah, you're not going to want that. The kerosene and used vegetable oil, again, kind of gave you the best of both worlds. It burnt well, had a good burn temperature. It was virtually odorless and smokeless. So I don't think anyone would be annoyed with that. So that's probably your go-to if you got people around. I think we made a lot of improvements on our waste oil burner. I do feel there's a few more improvements to come, and also integrate a water heater into this, because ultimately I want all this to do something useful, and my wheels are spinning. So stay tuned. I can't wait for version 3.0. Cheers.